All right, let's dive into the world of software architecture. And this isn't just about drawing a bunch of boxes and lines on a whiteboard. No, choosing an architectural style is more like picking a fundamental philosophy for how you're going to build your entire system. It really does set all the rules, the constraints, and, the possibilities for everything that comes after.
Okay, let's get the most important rule of the game on the table right away. It's the first law of software architecture. Everything is a trade-off. There are absolutely no silver bullets, no perfect answers. Every single choice you make that gives you a win in one area, like, say, performance, is almost certainly going to cost you somewhere else, maybe in complexity or how easy it is to maintain later on.
So that naturally leads to the million-dollar question. If there's no single best architecture, how in the world do you even start to choose? Well, that's the journey we're going to take today. We're going to explore 3 major architectural philosophies to really get a feel for their core ideas and, of course, the trade-offs they're going to ask you to make. So our first stop is the classic, the one where so many systems begin, the monolith. But, hey, don't just picture some giant messy blob of code. The real philosophy here is all about creating a clear separation of concerns, but doing it inside a single unified application. And the most common way to get that separation is with what's called a layered architecture. The idea is actually pretty simple, but it's really powerful. You just organize your code into these horizontal layers, and each layer has one very specific job. You've got your presentation layer handling what the user sees, the business layer with all the core rules, and the persistence layer which, talks to the database. And this right here illustrates that structure perfectly. Just look how clean and logical it is, right? Requests come in at the top, they flow down through the business logic, and then all the way down to the database. It's an incredibly organized and understandable way to build something, especially when you're just getting started. But remember that first law? Here come the trade-offs. The big strength of the layered monolith is its simplicity. It's straightforward to design, it's pretty cheap to get off the ground. The problem is, as the application gets bigger, all those layers, since they're all part of one single unit, they start getting tangled up. And that makes it really hard to deploy small changes, super difficult to test things in isolation, and a real headache to scale just one part of the system that's getting hammered with traffic.
All those weaknesses of the monolith, the deployment pain, the testing issues, the scaling problems, all of that led architects to a totally new philosophy. They thought, okay, instead of separating concerns inside one application, what if we built a system out of lots of small, independent applications? And that, my friends, is the philosophy of microservices.
The key concept you've got to wrap your head around here is the bounded context. Think of each microservice as owning its own little piece of the business world. It has its own code, its own logic, and, this is the real kicker, its own database. It's like its own self-contained universe. This whole approach intentionally favors being decoupled, even if it means you can't reuse as much code, all to gain that ultimate independence. Now, what's so fascinating when you look at this is how different it is from the monolith. The complexity didn't just disappear, it just moved. Instead of being buried inside one big application, all the complexity is now in the network. It's in the communication between all of these independent services. But the upside is each one of these can be developed, deployed, and scaled all on its own. And the trade-offs here are pretty serious. On one hand, you gain incredible agility. Teams can push out updates to their services whenever they want. You can scale just one tiny part of the system without affecting anything else. But the price you pay for that is a massive jump in complexity. You're suddenly managing a distributed system, you're worrying about network lag, and you're trying to figure out how to handle a single transaction that touches multiple services. It's incredibly powerful, for sure, but it is not free.
All right, let's switch gears and look at our third philosophy, which is a fundamentally different way of thinking. Instead of services explicitly telling each other what to do, what if they just broadcasted that something important happened and other parts of the system could just choose to react to it? This is the whole philosophy behind event-driven architecture.
So think of it this way. In the normal request-based model, you have a caller that makes a request and then just waits for a response. It's a command and control kind of thing. But in an event-based world, a service just publishes an event, like, say, order placed, and then it just moves on with its life. Any other services that happen to care about that event can listen for it and react whenever they want, asynchronously. The original service doesn't even know they exist. It's total, complete decoupling.
This slide is just fantastic because it shows you the real-world impact of that difference. Look at the top image. A user makes a request and is stuck waiting for over 3 seconds while the work gets done. That feels slow. But on the bottom, with an asynchronous event, the system replies in just 25 milliseconds, basically saying, hey, got it, we're on it. The user feels like the system is blazing fast, even though the total work still takes 3 seconds in the background. That's the power of responsiveness.
So the benefits you get from this reactive philosophy are huge for certain kinds of problems. Because all the components are so loosely connected, if one of them fails, it doesn't bring down the whole system. That gives you extreme fault tolerance. And because everything can happen in parallel, you can achieve massive scalability and incredible performance, especially under really heavy loads.
So, we've looked at 3 really distinct philosophies: the orderly separation of the monolith, the radical independence of microservices, and the reactive, decoupled world of event-driven systems. So let's bring it all back home to our original question: how do you choose?
This quote, man, it just nails it. Your goal as an architect isn't to chase some flawless, perfect design that doesn't exist. It's to find the design whose weaknesses, whose trade-offs, are the ones you can most easily live with. You're really just picking the least worst option for the specific problem you have right now.
At the end of the day, there is no universal right answer. The right philosophy depends completely on your context. If you're a small startup that just needs to ship something fast, a simple monolith might actually be your least worst option. But if you're a giant e-commerce site that needs to scale globally, then the complexity of microservices becomes a trade-off that you're willing to make. It always depends on the problem you're trying to solve. And that really brings us to the main takeaway. The real art of software architecture isn't about memorizing one style perfectly. It's about understanding the philosophy behind each one and the trade-offs they come with. So, as you start thinking about your next project, ask yourself, what are my biggest challenges? What pain points am I willing to accept? What's my building philosophy?